Okay, so this says maximize z equals x plus 5y, so that's going to be our objective function. And we have these constraints here, these four inequalities that we're going to graph. These bottom two, x is greater than or equal to 0, y is greater than or equal to 0. Remember, that just means that we are in the first quadrant. So as soon as I see those, I can just kind of draw the first quadrant like that. And then I know I don't really need these anymore. So it's a matter of just graphing these two things and then finding the feasible region. So I'll do this first one in blue and then this second one in red. So if we do the first one, I'm going to graph it using intercepts. So if I let x be 0, this x term goes away and I'm left with 7y equals 49. I treat it as an equal sign. I don't really care about the inequality until I'm ready to shade. So I get 7y equals 49, so if I divide by 7, I get y equals 7. If I let y be 0, well then this 7y goes away, and I'm just left with x equals 49. So let me do the intercepts for the second one, then we'll graph it all together. If I let x be 0, I get 3y equals 60, so y equals 20. If I let y be 0, I get 6x equals 60 or x equals 10. So now when I connect those, if I go back to the line, I have 0, 7. So I'm just going to kind of eyeball it for right now because I don't really care about exactly where all the points are. I just want to get an idea of what the feasible region looks like. So we'll say this is 0, 7. And then 49, 0, I'm just going to put way out here. 49, 0. And I will connect those with a blue solid line. And if I were to test 0, 0 in this equation to see which side I'm shading, I would get 0 plus 0 is less than or equal to 49. So I get a true statement. So I'm going to shade towards the origin like that. Now if I graph the red line, I'm going to start at 10, 0, which is somewhere right about here, to 0, 20, which we'll just put up here. This is 0, 20. I will now connect those with a solid red line. And then I'm going to test 0, 0 in the red equation. I get 0 plus 0 is less than 60, so that's also true. So my feasible region, if I look at the overlapping parts of these inequalities, it's everything to the left of the red and below the blue. So my feasible region is going to be this quadrilateral right here, this little box. So I have four corners when I'm looking at this box. I have 0, 7. I have the origin. I have 10, 0, and I have the intersection of the two lines. So I need to figure out what is the intersection of the two lines. Once I have these 4 points, I can plug them each into the objective function and figure out what's the max and which xy gives me that value. So to find the intersection, I'm going to solve this system. X plus 7y equals 49. I don't care about the inequalities, I just want to know where the lines cross. And the second equation is 6x plus 3y equals 60. So now the goal when solving a system like this is to get matching opposite coefficients in front of either one of the variables. So I could try and get the same number but opposite signs in front of the y's. Might be tricky because I can't multiply 3 by something to get 7. So in this case I'd have to multiply both equations by something. But I can get the same coefficient in front of the x's with opposite signs if I just multiply the first equation by negative 6. So then I'll have a negative 6x and a positive 6x. So when I do that, I'm going to multiply everything in the first equation and I get negative 6x minus 42y equals negative 6 times 49. What is that? That's 294. Let me just see that. 6 times 49. Yep, so that's negative 294. So when I add these down, the 6's being matching opposite coefficients will cross out. That's what I wanted. 3y plus negative 42y, that's negative 39y, equals 60 plus negative 294 is negative 234. So now just a matter of dividing by negative 39. We'll do 234 divided by 39. The negatives will cancel out, so this is y equals 6. So the y coordinate here is 6. So now I need to figure out what the x coordinate is. Well, just take that value for y and plug it back into either equation. If I plug it into the first equation, I get x plus 7 times 6 equals 49. So this is x plus 42 equals 49. So if you subtract 42 from both sides, you get x equals 7. So this coordinate, where the lines cross, looks to be 7, 6. So now the last step is to take each of the corners of my feasible region, 0, 7, 7, 6, 10, 0, and we pretty much know the answer is not going to be 0, 0, but we'll try it anyway, and plug each of them into the objective function for x and y. So if I do this, I get 0 for x, 7 for y, so I do 0 plus 35, that's 35. If I plug in 7, 6, that's going to be 7 plus 5 times 6. That's 7 plus 30. That's 37. So I know this isn't the answer. If I plug in 10, 0, I get z equals, well, that just means the x is 10, so I get z equals 10. So I know this isn't the answer. And the last possibility would be 0, 0, in which case I just get z equals 0. The problem with your answer is that this point is not part of the feasible region, right? We don't test that point and we don't test that point because they're not members of this overlapping of shaded areas, this yellow quadrilateral. So we're only testing these 4 points in the objective function to see which is the largest. So the maximum here would be 37, x would be 7, and y would be 6.